Hello friends, in today's question, a chain of mass 10 kg and length 8 meter is resting on a rough horizontal surface with coefficient of friction is 0.2. A force F of 12 Newton is applied as shown. Find the length of the chain on which no friction force acts. So this is chain of length L. M is mass, mu is the coefficient of friction, and F is force which is being applied towards right side. So let us find out that the maximum frictional force. So if this is a chain, so there will be mg in the downward direction. So F is here, so there will be frictional force Fr which will be acting in this direction. So we can say that the maximum value or the limiting value of the friction, the maximum value of friction force, and let us call this as Fr max. This will be equal to, and there will be normal in the upward direction. This will be mu into n, so n will be equal to mg, so this will be mu mg, and mu is given as 0.2, mass is 10 kg and g is taken as 10. So we can say that our Fr maximum value is equal to 20 Newton and the applied force is 12 Newton. Okay, say the applied force F is 12 Newton. So if you make a comparison between the maximum value of the friction and applied force, you can clearly see that the limiting value of friction Fr max is greater than the applied force F. Therefore, the chain will not move. Now let us find out the frictional force per unit length. You can see frictional force per unit length, and this will be equal to, the length is 8 meter and frictional force is 20 Newton. So we get this as 2.5 Newton. Now let me draw the chain here again once again. So we have a force in this direction, frictional force, and there will be also tension T which will be acting in opposite direction. Okay. So as the chain is not moving, so we can write the equation for and we can say because of the length of the chain, tension T will act in opposite direction, that is to leftward, along with frictional force F. along with Fr. Therefore, we can say as it is not moving, the forces will be balanced. So we can say F will be equal to T plus Fr, and from here you can write that tension T will be equal to F minus Fr. Let us call this equation number 1. And we also say that we consider the length from the right to be as x. Okay, so let us consider length from the right to be as x. Considering the length of the chain from the right side equal to x meters. So from here we can say force in the length of x meter, frictional force rather, you can say frictional force for the length of x meters will be equal to 2.5, which is frictional force per unit length multiplied by x. And secondly, if you put value of this frictional force in equation 1, so we can say from equation 1 tension T will be equal to the applied force F is of 12 Newton. Applied force is 12 Newton. Yeah, it's 12 Newton. And this will be minus 2.5 into x. Okay. And we want that if tension is to be 0, you can say for tension to be 0, this equation 12 minus 2.5x should be equal to 0. So from here we can say x is equal to 12 divided by, this will be 120 divided by 25, and we can cancel it. This will be coming equal to as 5, and this will be 2, and 24. So this will be 24 upon 5, and so the x will be coming equal to as, you can say this will be approximately 4.8 meters. Therefore, we can find out the chain length at which no friction force is going to act. Therefore, the chain length, the length of the chain in which no friction force will act will be equal to, total length is 8 and minus 4.8 meters, and this will be coming approximately equal to as, this will be I think 3.2 meters. Yeah, so this is the final answer. So the length of the chain will be, you can say, 3.2 meters, where the frictional force won't act. So this completes the question. Thank you.